Pause the video and try to analyze this code on your own. If you want, you might try to start figuring out the order, but realistically, this code would need to be rewritten a little bit. I'll do that once you analyze this version. Ready? Go ahead and pause the video now. Okay, I hope you got a better sense of what this script is doing. I'll start by rewriting this code into a more synchronous form. Since async await is just syntactic sugar for promises, I can rewrite above code example into promises. Looks a bit like a pyramid of doom, I admit. However, now this script is organized into synchronous blocks, which are much easier to read. On line 1, setImmediate is scheduling a callback for check phase in the next iteration of the event loop. Console.log on line 2 is executed immediately by the context, so console.log gets printed to the console. Resolved promise is created on line 3 and put onto the promises microtasks queue. Because we're at the initial phase of Node processing the script, the event loop is initiated but is not processing the code just yet. After scheduling that promise.resolve callback, we step into the first iteration of the loop. The current call stack is empty, therefore the queued up microtask is pushed onto the execution stack. The callback, starting on line 4, calls setTimeout, which in turn registers its callback with the timer's phase for the next event loop iteration. That promise from line 3 had only one callback, therefore there's nothing else to be executed. Promise.resolve callback gets popped off the stack. In the current event loop's iteration, there's only one phase with a callback scheduled, and that's the check phase. The callback gets pushed onto the execution stack, gets executed, and setImmediate, originally registered on line 1, is logged to the console. There are no more callbacks for this event loop iteration, therefore it completes. There is a callback scheduled for the timer's phase of the next iteration. The setTimeout was called without a timeout value, so it defaults to 0. Its callback gets pushed onto the execution stack. setImmediate on line 5 puts its callback into the check phase of the next event loop iteration. Now the promise from line 6 gets immediately resolved, registering its callback. There are no more macro tasks for current event loop iteration. There is one microtask callback in the promises micro queue. As always, microtasks get executed between macro phases. Therefore, callback from line 7 is executed, but all it does, it schedules yet another callback via setImmediate into the check phase of the next event loop iteration. Now the promise micro queue gets emptied. No more microtasks, neither macro tasks for this event loop iteration, therefore it ticks over to the next one. Let's jump straight to the check phase where there are some callbacks. Both get pushed onto the call stack in FIFO fashion. setImmediate2, originally registered on line 5, gets logged to the console. Then the other callback scheduled by setImmediate from line 7 gets executed. Line 8, another setImmediate schedules callback for check phase of the next event loop iteration. Console log 2 on line 9 is synchronous, therefore gets immediately logged to the console. On line 10, another promise resolves. Its callback gets put onto the microtask queue as always. Check phases queue for this event loop iteration is cleaned out. Time for microtask queue. The callback gets executed. Another setImmediate on line 12 schedules callback for check phase of the next event loop iteration. Then line 13 gets executed immediately, so console log 3 gets printed to the console. And promise.resolve callback is popped off the promises micro queue. Microtask queue is now empty. So is the microtask queue. Iteration 3 of the event loop is done, on to the fourth one and last. This one's finally pretty straightforward. Only two callbacks in the check phase, setImmediate 3 and setImmediate 4, both of which get printed to the console in that order. As you can see, this example, although looked pretty scary in the beginning, is actually much easier than the one from the previous lecture, because there are no special cases to consider and there's much less callbacks scheduled for each iteration of the event loop. If you get this type of question during your interview and there is async await code involved, I highly recommend rewriting that into promises, just like we did here, to make the code more readable and synchronous.